So this is 2009 5 big. Now, the main problem with this one, main problem with most students doing a question like this is they're not used to going up and down instead of left and right. So, lucky for us, the discretion is on us as to what system we want to use. So what I do at the start of the question is this: I get it, and I simply turn it around. And I can even do it that way if I want. In fact, that's the way I'll do it. Just rotate it all the way around and treat it like a normal question. And then at the very end, you can change it back into vertical motion. Okay, there's no need to be worried about anything, okay? So all that the question asks is, show that A equals 30 degrees. That's no bother. And then coefficient of restitution, the E value is 4/5. That's no bother there either. Stationary. So if we do a before and after picture, that's are they both mass M? Both mass M. This one goes at speed. It's going in two different speeds, isn't it? It's going up and across, so I can't write that down just yet. They're both identical smooth sphere big, so they're both M. Okay. So I have to prove that the first one is that alpha equals 30 degrees. So look at this. Draw your center of your circle. Link your center of your circle up here. So it's a tangent, yeah? You looking, guys, or do you know this already? That's R. That's 2R. That's a 90-degree angle. Therefore, sine alpha equals R over 2R, or opposite of our hypotenuse, which equals a half. Alpha equals sine inverse a half. That's going to get you your 30 degrees straight away. Everybody happy enough for that? Now that we know that's definitely 30 degrees, what we're going to do next is we're going to break up our components. So we know that that's going U. So it's going this direction here with speed U. That makes that one U cos alpha, and that makes this one U sine alpha. But we know alpha is 30 degrees. So technically speaking, it's U cos 30 and U sine 30. U sine 30 and U cos 30. What's cos 30 again? Cos 30 is root 3 over 2. So root 3 over 2 U, and the other one? Huh? Just U over 2. Now this is the before picture. What about the after? So the after picture looks like what, guys? How did they collide with each other? They collide along their centers. So they collide along this line here. That means what about this, the U over 2? Sorry? The U over 2 is preserved in the next part, okay? So you still are going with U over 2 across, but what you have going across instead is V1. What about the second particle? Does it have any velocity going upwards? No, because all the force was directed along this path here. So that means it only goes across with V2. Once you have that set up, guys, you have to find the direction which each sphere travels after the collision. It's the same setup we always use. PCM. M1U1 plus M2U2 equals M1V1 plus M2V2. Please keep an eye on me, okay? It's very easy. It's very easy to make a mistake. Okay, I'm going for M times root 3 over 2U. The U1 speed here. I'm going for M times 0. And then going for MV1 plus MV2. I'm then going to determine that V1 plus V2 equals root 3 over 2U. Okay, so that's the first one done. Everybody alright with that? Okay, so that's it there. I'll just group it and store it down here. Okay, next thing I'm going to do is NEL, Newton's experimental law, where V1 minus V2 equals minus E into U1 minus U2. What's our E value? 4 over 5. Phi 1 minus phi 2 equals minus 4 over 5. Now U1 minus U2 is going to be root 3 over 2U minus U2. Anybody? U2? 0. Cross multiply the 5. 5 phi 1 minus 5 phi 2 ends up to be minus 4 root 3. Oh, sorry, that's it. There's a 2 there as well, isn't there? So all over 2U. 4 over 2. Basically, get rid of that and then just put 2 here. 2 over 3U. What was my answer again? Yeah, it's got the same thing. It's okay. Now, going to do next, guys, is going to combine this red equation here. Going to multiply the red equation by 5. So I'm going to get 5 phi 1 plus 5 phi 2 ends up to be oh, wait a second. Don't necessarily want that either. I'm going to get rid of the fraction. I don't want the fraction, so I'm going to call that 2v1 plus 2v2 equals root 3u. Everybody alright with that? What's the lowest common denominator between 5s and 2s are 10s. So we're going to multiply the blue equation by 2 and the red equation by 5. So we're going to get 10v1 minus 10v2 equals minus 4 root 3u. And then the other one we're going to get 10, red one we're going to get 10v1 plus 10v2, 5 root 3u. Add them together, we're going to get 20v1 equals root 3u. Phi 1 equals root 3u over 20. Yes, okay. I'm going to manipulate the equation up here. I'm going to call that minus, minus, minus. And I'm going to do it again. This time the 10, oh sorry, this time the 10v1s cancel. I'm going to get minus 20 phi 2 equals minus 9 root 3u. Multiply both sides by minus, then divide by 20. Phi 2 equals 9 over 20 root 3u, or root 3 and then u on the outside. Everybody alright with that? Okay. Now, find the direction in which each sphere travels after the collision. The direction, okay? So what you say is that phi 2 travels directly to the right. So use it as I and j components. So phi 2 equals 9 root 3 over 20 u, I, means going directly to the right, plus 0, j, not going up or down. Phi 1, however, is different. What's phi 1 doing? It's going root 3u over 20, I, because it's going to the right, but it's also going upwards at u over 2. J. Just give me a minute to finish this off. Okay, so everybody happy with those two velocities? Keyword wasn't speed. Keyword is that they're looking for the direction. So I had to give the I and j coordinates, okay? Now, I still actually haven't, I could probably convert it to angle even. I could convert it to an angle, so I might just give an angle as well while I'm here. This one's going up and across, yeah? So what's that? Root 3 over u 20, and that's u over 2. Find out what this angle is, angle x, call it. What are tan inverse, guys, on my calculator? Yeah, 1 over 2 divided by root 3 over 20. And that's 80.17, yeah? 80.17 degrees, okay? Now, you may need to convert that to what, guys? You may need to convert it back to that there, yeah? That you're going, you're technically going this direction here. A is technically going over here, isn't it? And that's 80.17 degrees. There. Everybody right with that? Cool. Now, find the percentage loss in kinetic energy due to the collision. Oh, beautiful. Kinetic energy, percentage kinetic energy loss again, okay? So all I have to do is this. Very repetitive. Percentage KE loss equals KE before minus KE after divided by, anybody? KE before multiplied by 100. Now, what is the kinetic energy before? K before is, it's going at U at the start, wasn't it? Speed of U at the start of the question. So it's a half mu squared. Now, the problem with the after is that, see this here? We have to get its hypotenuse, because kinetic energy is related to the speed. So I have to break it up. I have to do Pythagoras' theorem here. So it's going to be root 3 u over 20 squared plus u over 2 squared. So I'm just going to go to the calculator. I'm just going to do root 3 over 20, square it, square the answer, add it onto a quarter, because half squared is a quarter. Got that number there. Going to root the answer. Root 103 over 20. It's a fairly awkward number. Okay. So that's root 103 u over 20. Everybody alright with that? Okay. So what we're going to do next is k before minus k after. Okay. So we also have phi 2, and we also have the velocity. We have two different particles, both of mass m. So to get the kinetic energy afterwards, okay, just get rid of all this for a minute. So kinetic energy afterwards is going to be this: a half m times root 103 u over 20 squared plus a half m multiplied by 9 root 3 over 20 squared. Now that is pretty major looking, isn't it? So do I even have it here? Okay, 173 all over 200 mu squared. Okay, so what's our loss going to be then? Yeah. So guys, enter this all into the calculator. You get a half times root 103 over 20 squared plus 0.5 9 root 3 over 20 squared. So basically a half 9 root 3 over 20 squared. Put all that into the calculator, and what you get is 173 over 400. So 173 over 400 mu squared. Now, kinetic energy loss. So we're going to put all our numbers into the kinetic energy loss equation. It's going to be a half mu squared minus 173 over 400 mu squared over kinetic energy before, which is a half mu squared multiplied by 100. So in effect, the mu squareds cancel. So what we have is a half minus this, which is going to be 27 over 200. Or sorry, it's going to be excuse me, it's going to be that's the same thing as 200 over 400. So it's going to be 27 over 400 divided by a half, which means when you bring up the half, it's going to be multiplied by 2 over 1, which is going to be 27 over 200 multiply by 100, and you get a loss of 13.5%.